Okay, so we're finishing the notes from 141. I hope you're doing well, and I hope this helps. So here we go. In this, I can't remember where we left off, so I'm just going to start here, and if you want to fast forward a bit, that's fine. But we're writing a second degree Taylor, and as I am learning this, it helps to write this. The more I write this, the quicker it gets into my brain, and it also serves kind of as the template that I'm going to plug into. So, based on what they give me, in this case, it looks like point, I know things about f for our x equal 1, so that's going to be my c. C is going to be 1. And so, oops, this should be Taylor at any x. So the second degree Taylor for any x would be, and that also is not true, f at c, which is 2. F prime at c, 3. X minus c is x minus 1 to the first over 1 factorial plus 5 times x minus 1 squared over 2 factorial. All right, that's a nice easy one to start with to give you everything you need. I know I did this in one of the classes, but not the other. So this one, we need, if I'm going to write a second degree Taylor, then again I'm going to need to go f at c, f prime at c, and f double at c, and I'll get all of those from the picture. And in this case, c is 1. They tell you that. That's easy enough to see. All right, so let's try f at 1. Now, if this is f prime, then I need to either integrate it or do fundamental theorem kind of thing. Because I just want specifically a 1, I'm going to do fundamental theorem. So that would be f initial plus the change from 0 to 1 under f prime. So that's 3 plus triangle area. And so I'm getting something like 3 plus, units are kind of crazy, 1 times 10 divided by 2. So I'm getting 8 for f of 1. F prime at 1 is just reading the graph. It looks like 10. And f prime, f double at 1 is the slope of f prime. If it's rising 20 over 2, then the slope is 10 as well. So, writing my Taylor, I'm getting something like 8 plus 10 times x minus 1 to the first over 1 factorial plus 10 times x minus 1 squared over 2 factorial. All right? Did that go okay? All right, moving on. Sometimes they give you a formula for the derivatives, and that's what's happening here. So they say there's a horizontal tangent at 0, 5, so that gives me something about the derivative. It also gives me something about the point at 0, that the f value is 5. So that horizontal tangent at 0, 5 tells me two things, that f prime at 0 is 0, and f prime at, or f of 0 is 5. All the other derivatives from second on up are given by that formula right there. All right, I got you. So, does the function have a min, max, or neither at x equals 0? I definitely don't want to do a sign test because I don't have the first derivative to work with. So the first derivative test is out. I'll use the second derivative test. I know I have a flat spot from the horizontal tangent. Now let's test the second derivative at x equals 0. So the second derivative at 0 would be negative 1 to the 0, nope, to the 2, and represents the number of the derivative. Negative 1 squared, 2 plus 1 factorial over 4 squared, 2 minus 1 squared. So that's positive 1 over 3 factorial, 16 times 1. So 6/16 or 3/8 is greater than 1. So I conclude that I have flat with concave up, so I'm going to have a min. F has a min. x equals 0 because the first derivative is 0. Horizontal tangent, that's why I say that. And f double is greater than 0. All right. The third degree Taylor for the function. So I have the second derivative is 3/8. I need the third derivative. So f triple, or the third derivative, would be something like -1 cubed, 3 plus 1 factorial over 4 cubed, 3 minus 1 squared. So maybe -1 over, or times 4 factorial over 4 cubed times, what do we got, 4? So many 4s. I guess I could simplify this. You don't have to. I get what? -3 factorials if I cancel out a 4, so -6 over 64. So -3/32. So here's my third degree Taylor. F at 0 is 5. F prime at 0 is 0. F double at 0 is 3/8 times x minus 0, or just x squared over 2 factorial minus 3 over 32 x minus 0, or just x cubed over 3 factorial. All right. Pretty straightforward. All right, now these take some skill, they take some practice, and once you learn the approach, they're not too bad. They're very common multiple choice. So, it goes like this. Based on what you see in a series, you should be able to extract information about the derivative. The most important thing getting started is to understand that f double will be directly connected to x minus 2 squared. So you're going to look for x minus 2 squared. Don't worry about the factorial in the bottom. The coefficients can change a lot. The only thing that you can be absolutely sure of is x minus 2 squared is the coefficient, or is the factor that goes with the second derivative. So after I have identified where I'm going to look, then I usually set the formula generally equal to the term. Now the general formula for Taylor is the second derivative at 2 times x minus 2 squared over 2 factorial. That's how I would generate the second degree term according to the formula. In this case, equals 3 times x minus 2 squared over 4 factorial. With that, then, you can dump the x minus 2 squareds. They've served their purpose. And I have f double of 2 over 2 factorial equals 3 over 4 factorial. And so, solving for f double, it must be 2 factorial times 3 over 4 factorial, or I guess 1/4. So, with that in mind, let's look at the next one. F prime at 2. For f prime, I need to look for what is x minus 2 to the first. Well, x minus 2 to the first does not show up. Well, the only way that cannot show up is the derivative is 0. The factorial obviously can't be 0. So it must be the case that f prime at 2 equals 0, because there is no x minus 2 to the first here. It's at the second. So the derivative must be 0. All right? Last but not least, the much harder one is the 20th derivative at 2. What must the 20th derivative at 2 be? Now, I would typically start, like I said, start with the formula. The 20th derivative at 2 would be attached to x minus 2 to the 20th over 20 factorial, but I don't see x minus 2 to the 20th here. I could build out to it. it wouldn't take too long. The exponents are going up by 4 or 2 each time, so I guess I could do that, but instead, let's talk the general term here. So the general term is x minus 2 to the, and the exponent each time is even. So x minus 2 to the 2n. The minute I say that, that implies that n started at 1, yeah? All right. If I then go to, let's go to the denominator factorial. The denominator factorial looks like it's 2 more than the exponent, but also even, so it's going to be like the exponent but plus 2. And I think that works. Starting with n equal 1, I would get a 4 factorial. That works. All right. Then let's go to the 3, 9, 27. That seems like it's 3 to some power. And it looks like starting at 3 to the first, and then 3 to the second, and 3 to the third. So that seems like it's just 3 to the n. 3 to the first, 3 to the second, 3 to the third. And then last but not least, the sign, negative 1 to the n, or n plus 1. Well, if it were n, it would start off negative 1 to the 1, and that would be negative. I'm seeing a positive first term here, so it must be negative 1 to the n plus 1. All right, now I got the general term nailed down, and that took a while, but you'll get better and better at that. So let's talk about then what the 20th term would look like. If I were talking x minus 2 to the 20th, then that seems like that implies that the n would have to be 10. So let's find out all the other components to that. Down in the denominator, that would mean 22 factorial. That's logical because we said the denominator is always 2 more than the exponent. The exponent for the 3 would be 3 to the 10, and the sign is going to be negative 1 to the 10 plus 1, or the 11, so that'll be negative. All right, now we're back like we were over here, where we can, first of all, dump the x minus 2 to the 20th and isolate the 20th derivative. So the 20th derivative would be what this right side comes out to be times a 20 factorial. So in terms of simplifying, let's call that 22 factorial 22 times 21 times 20 factorial. We dump the x minus 2 to the 20th, and the top is a negative 3 to the 10th. I'm not touching that, that's hideous. So I think the 20th derivative, and probably at the multiple choice you'd see if this were a multiple choice, is negative 3 to the 10th over 22 times 21. That's about as ugly as you're going to see. That's pretty gross. All right? So we started with the general term so that we could figure out the 20th term. And once we knew the 20th term, then we could isolate the 20th derivative. All righty. So then let's look at one like this. I think these are both on the homework. So if you want to try this on your own, you can pause the video and see how it goes. It's the same idea, or you can do the ones on the homework. If you're watching this video, you can, and you're doing these on your notes, then you don't have to do these on the homework. I apologize. I didn't realize I don't know. I don't know what I messed up, but you only have to do them one place. All right, so if it's in your notes, that's fine. Thank you for watching this. All right, so assuming you gave this a try, if you wanted to on your own, then let's talk about what this looks like. So here we go. This is a little wackier because there's different growth rates. We'll talk about that in a minute. But f prime at 2. So f prime, gosh, I think this was supposed to be attached to that. Sorry about that. F prime at 2, I'm going to look at x minus 2 the first, because it's first derivative. I want to find the first power term, so that's this guy. I'm going to write the general term, f prime at 2 times x minus 2 to the first over 1 factorial equals, in this case, 4, x minus 2 to the first over 2 to the fifth. So f prime at 2 is 4 over 2 to the fifth. Did you get that? I knew that you would. All right. The ninth derivative, we're going to look at x minus 2 to the ninth, which is here. That implies that the ninth derivative at 2 times x minus 2 to the ninth over 9 factorial comes out to be 12 times x minus 2 to the ninth over 2 to the 21st. The x minus 2 to the ninth can be divided out, so the ninth derivative at 2 then is 12 times 9 factorial over 2 to the 21st. Whatever that might be. All right. The 20th derivative. It seems like that's bogus. Here's why. These exponents are going up 4 each time, so if I go up to the next, it would be to the 13th, then to the 17th, then to the 21st. There isn't a 20th power x minus 2, so that implies that the 20th derivative has to be 0. And then the one that got split into a separate line, that was supposed to read the 21st derivative at 2. Now that does come here. So we're going to start by writing the general term. And then we'll find the 21st term, and then we'll isolate the derivative. All right, so let's start off with the x minus 2. Look at the exponents here. And what you see is a arithmetic sequence. They're going up by 4 each time, so that makes it linear. So the rate of change is 4. That means it's going to have a slope of 4, or go something like this. I typically start, I don't know, I usually think n starts at 0 because that's what the Taylor series usually starts off with, is the 0th derivative. So if I start at n equals 0, then this needs to be 4n plus 1. That way, when n equals 0 goes in, I get x minus 2 to the 0 plus 1. That seems to be working. Now let's go to the 2. Those are 2 to the powers, and those seem to be going up by 8 each time. So that means 2 to the 8n plus, and as far as what it's going to have to start off at, if n starts at 0, then I would have to go 8n plus a 5 to start with. And I think that works. When n equals 0, I get 2 to the 5th. When n equals 1, I get 2 to the 13th. I think that seems good. Let's talk the 4, 8, 12. Those are going up by 4 each time. So they have a slope of 4. And they seem like they are starting at 4. So I need to do kind of a starting point of 4 so that when n equals 0, I get a 4. And when n equals 1, I get 4n plus 4. That seems good. And then last but not least, the sign. Negative 1 to the. I want to start off positive, so negative 1 to the n works, not n plus 1. So there's my general term. All right? There are other possibilities. If you thought I started n equal 1, then it might be something like 4n minus 3. Yeah, 4n minus 3 for the exponent, and 8n minus 3 for the lower exponent. You could do that. So there are other possibilities. Now, I need to figure out what the 21st term would be. So the 21st derivative, or the 21st power x minus 2, generally speaking, by Taylor series formula would look like that. Now in this case, the only way I'm going to get a 21 out of that formula is if n equals 5. So I should think, all right, what would this look like if n equals 5? Well, I definitely get x minus 2 to the 21st, which is good. That absolutely has to match. These have to be identical, the coefficients. All right, now if n equals 5, then the bottom is 2 to the 45. Shoot, that's big. When n equals 5, this coefficient here is 24. And when n equals 5, I get a negative. Now I can isolate the 21st derivative. The 21st derivative at 2 is negative 24. These guys drop out now. Negative 24 times 21 factorial over 2 to the 45th. That is not something I'm going to do by hand, so I guess I'll just leave it like that. That's pretty gross. All right. With practice, those get better and better. It's just a process you have to get to know. All right. Find the coefficient of the 15th term of the Maclaurin 4. Now this goes to pattern recognition. I don't want you to necessarily take 15 derivatives, but let's look for patterns here. The 15th term, let's start off with, first of all, the 15th term would be, Maclaurin implies that the center is 0. So the 15th term, you have to ask yourself, does that mean the 15th derivative or the 14th derivative? And what's the pattern involved? Well, because it starts with no derivative, you could say it kind of starts at 0. So the 15th term would be when we get the 14th derivative at 0, x to the 14th over 14 factorial. That's the 15th term. Oops. All right. So I need to figure out what's that going to look like. What's the 14th derivative? Let's look for patterns here. No derivative is e to the x at 0. That's e. E to the 2x at 0, which is, oops, not e, 1. I'm dumb, sorry, is 1. All right, now chain rule. As you take the derivatives, you get a 2e. So that's 2e to the 2x, which at 0 would just be 2 times 1. The second derivative is another 2. So 2 squared e to the 2x at 0. So 2 squared. The third derivative, it seems like I see the pattern, is 2 cubed e to the 2x at 0. So 2 cubed. So the 14th derivative will be 2 to the 14th. So if they say what's the coefficient, be careful. The coefficient, remember, has two components. The coefficient is the derivative, 2 to the 14th, and the factorial. So the coefficient would be 2 to the 14th over 14 factorial. All right, what about the 24th term of sine about x equals pi over 4? Is it positive, negative, or 0? If it's about pi over 4, then it's a Taylor. So the Taylor would look something like f of pi over 4 plus f prime at pi over 4, x minus pi over 4 to the first over 1 factorial, f double at pi over 4, x minus pi over 4 squared over 2 factorial. So first question, the 24th term. Is that x minus pi over 4 to the 24th, or is it to the 23rd? And it is to the 23rd, because again we're starting with no x minus pi over 4s for the first term. So the exponent is always lagging behind one less. So by the 24th term, we'd be at x minus pi over 4 to the 23rd over 23 factorial, and I need to figure out what's the 23rd derivative of pi over 4 at pi over 4. All right? So let's again get into the pattern and look for patterns. So if f at pi over 4 is sine at pi over 4, that's root 2 over 2. F prime at pi over 4 is cosine at pi over 4, and that's root 2 over 2. F double at pi over 4 is negative sine at pi over 4, that's negative root 2 over 2. F triple at pi over 4 is negative cosine at pi over 4. That's negative root 2 over 2. And then that's a full cycle. You'll see that these typically go in groups of 4, and then we'll get back to a pattern. So f, the fourth derivative is f at pi over 4. It's back to positive sine at pi over 4, and it's root 2 over 2 again. All right. So, the 0th through the 3rd is one full cycle. So there might be a more efficient way to do this, but this is what I think. From 0 to 3 is right back to where it started, and then from 4 to 7 is right back to where it started, and then 8 to 11 is a full cycle, and then 12, I'm adding 3 each time. 15 is a full cycle, and 16 through 19 is a full cycle, and then 20 to 23 is a full cycle. Now 23 then would be like the last term in the pattern. 23 would be like 3 behaves. Well, 3 is negative, and so I would say that the 23rd term is negative. If they asked for the coefficient, I guess it would have been negative root 2 over 2 over 23 factorial. Huh. Like I said, there's probably a better way to do it, organizing and saying a pattern, but that works for me. All right, I believe that is it. So again, I'll say that I mistakenly put a couple problems on there on both the homework and the notes, so you don't have to do them again if you paid attention to this video. I hope you're having a good weekend and you're healthy. Have a nice day.